So guys, let's discuss the JEE Main pattern exercises for limits and derivatives. The first question is talking about limit. It says limit x tends to pi by 6. What is the value of this particular function? Now see, over here it's pretty simple to understand. The numerator will be broken as 2 sine square x plus 2 sine x minus sine x minus 1, right? And the denominator will be broken up as what? 2 sine square x minus 2 sine x minus sine x plus 1, and you need to evaluate the limit as x approaches to pi by 6, right? So what happens in the numerator? Your 2 sine x comes out common. You are left with sine x plus 1 minus 1 sine x plus 1. In the denominator you have again 2 sine x common. Sine x minus 1 minus 1 sine x minus 1, and again limit as x approaches pi by 6. So clearly you can see you have sine x plus 1 into 2 sine x minus 1, sine x minus 1 into 2 sine x minus 1. 2 sine x minus 1 gets cancelled from the numerator and the denominator. You are left with sine x plus 1 upon sine x minus 1. You know that this is continuous, denominator is not vanishing at pi by 6, so I am just going to incorporate the very value of x equal to pi by 6 to get the limit. Now what I get is 1 by 2 plus 1 upon 1 by 2 minus 1. So you get what? 3 by 2 whole upon minus 1 by 2, which brings the answer as minus 3. So the limit of this expression very easily can be calculated by just breaking the middle term and then solving the expression to get the value of the limit as minus 3. Next question says what? It says if the value of this particular expression is 100, then what is the very value of n for which this is 100? So over here, very nicely I can talk about the application of this result, that limit x tends to a, x to the power n minus a to the power n whole upon x minus a is n a to the power n minus 1, right? How can I apply this result over here? See, look at the expression, limit x tends to 0, 1 minus x to the power n minus 1. Now this 1 can be written as 1 to the power n, not a problem, right? Then you have in the denominator you have x. So basically to create 1 minus x, you write it as 1 minus x minus 1. But when you resolve this, you actually get minus x in the denominator, right? You get minus x in the denominator, not x in the denominator. This value is given to you as 100. So minus of this value is going to be equal to minus 100 because there is a minus sign extra. And now things are completely replicated as per this. Why? Y to the power n minus a to the power n whole upon y minus a. I only need that y should tend to a. So if I take 1 minus x equals y, I have y to the power n minus a to the power n whole upon y minus a. What I just need is limit y approaches to 1, and that is very simple. If x is approaching to 0, if x approaches to 0, minus x also approaches to 0. So 1 minus x approaches to 1, that means y approaches to 1. And this is exact copy of this. This is n into a to the power n minus 1. This thing is given to you as minus 100. So this expression is n into a to the power n minus 1 is minus 100. That means n is minus 100, and therefore your answer is option number B, that is minus 100. The next question says that the value of this particular limit is what? Okay, so let's try to evaluate. So all types of question we would be watching in limits. Over here, if you see, Now this is pretty nice. This is x tends to infinity. Whenever x is tending to infinity, we try to bring all x and powers of x in the denominator, so that as x tends to infinity, 1 upon x tends to 0 and the world is simplified. So what we do in here is, we basically try to take out x square common, and from the square root, when x square comes out common, it becomes obviously x. So I basically write it as x square. Inside I have 3 minus 1 by x square plus under root x square 2 minus 1 by x square. In the denominator also, I don't want x over here, I am going to take it in the denominator then. So I have x common, 4 plus 3 by x. Very clearly, square root of x square is going to be x, square root of x square is going to be x, so x is going to come out common from the entire numerator and get cancelled. I have limit x approaching to infinity. So now what you are left with is under root. Now if you put x equals infinity, as x approaches infinity, 1 upon x approaches to 0, 1 upon x square approaches to 0. So this expression is just root 3. Similarly, this is root 2, and in the denominator it is a 4. Because as x approaches infinity, 3 upon x approaches 0, minus 1 upon x square approaches 0. So this is what you are left with, and therefore when you rationalize it, what you get is root 3 plus root 2 into root 3 minus root 2 by 4, which becomes what? 1 upon, here also you will be multiplying this expression. This will be 1 upon 4 into root 3 minus root 2, and that is your answer. Clear? Pretty easy stuff. Then we have the value of limit of this expression is what? Okay, so let's evaluate. Limit n tends to infinity of this expression. Now see, you can see this is 1, 2, 3 and so on up till n. And then there is 2, 3, 4 and so on up till n plus 1. Whatever is n, one more is the adjacent term, right? And that is happening in every term of this expression. So I can write this as what? Limit n tends to infinity r, or let me write summation r into r plus 1, r going from 1 to n. For r equals 1, this is 1 into 2, plus for r equals 2, it is 2 into 3 and so on. For r equals n, it is n into n plus 1. So what you get in here is, this is limit n tends to infinity summation r square plus summation r. You know the value of these summations? This is limit n tends to infinity, this is n into n plus 1 to n plus 1 by 6, right, plus n into n plus 1 by 2. Fine. So over here, very simply what we can do is, I can take out the LCM. What I will be left with is n into n plus 1 to n plus 1 plus 3n times n plus 1 whole upon 6. Fine. So this becomes limit n tends to infinity, limit n tends to infinity, n into n plus 1 is going to come out common. You will be left with 2n plus 1 plus 3. 2n plus 1 plus 3 means 2n plus 4 whole upon, this is what? N into n plus 1, 2n plus 1 by 6, and this is what it is, and over here you have n cube also in the denominator. So this becomes whole upon n cube, this is whole upon n cube, here also you have n cube. So numerator becomes this, denominator you have 6n cube. So n gets cancelled out, you have limit n tends to infinity, n plus 1, 2 comes out common, you have n plus 2, 6n square. This is 2 gets cancelled out, this is 3. From here again, because n is tending to infinity, I would want it to come in the denominator. N comes out common, I get 1 plus 1 by n. Another n comes out common, I get 1 plus 2 by n whole upon n square. 3n square. Right? This gets cancelled out as n tends to infinity, this tends to 0, this tends to 0, so you get 1 by 3 as your final answer, and that is what is your very correct option. That's how you compute this limit. Next we have question number 5, limit x tends to 0, 4 to the power x minus 1 upon 3 to the power x minus 1 equals what? Okay, so let's try to understand. Over here the one very natural thing which triggers is limit x tends to 0, a to the power x minus 1 whole upon x is log a to the base e. Fine. So over here if I talk about this expression, I can rewrite it as limit x tends to 0, 4 to the power x minus 1 whole upon x. This is what I want ideally, to use this. So I multiply and divide by x. Rest of the expression remains the same. Obviously limit of the product is product of the limits. What is this? I can write this as limit x approaches 0, 4 to the power x minus 1 whole upon x multiplied by limit, or let me write it as 1 upon limit x approaches 0, 3 to the power x minus 1 whole upon x. I can write like this, right? I can write this as 3 to the power x minus 1 whole upon 1 by x, right? And therefore what I get is, this is what log 4 to the base e divided by, this is what log 3 to the base e, which is nothing but log 4 to the base 3, and that is what is your answer. Clear application of this result. Fine, just a bit of manipulation and you have your answer. Then you have limit x tends to infinity, 1 plus 2 by x whole to the power x equals what? Let's see. Now over here the moment x is in power, I am able to recall one result which says limit x tends to a, 1 plus fx whole to the power 1 by gx is equal to e to the power limit x tends to a fx by gx. Understood? So in order to use this, how is this particular expression helping me? 1 plus 2 by x, so let me take this as fx and this is my 1 by gx. If this is 1 by gx, what is gx? So if x is 1 by gx, if 1 by gx is x, then clearly gx is 1 by x. So now I have limit x tends to a, 1 plus fx whole to the power 1 by gx, which is equal to limit e to the power limit x tends to infinity fx, which is 2 by x, fx upon gx, upon 1 by x means multiplied by x, and this gives you e square as your answer. Clear enough? Then we have what as the next question? It is limit x tends to 1 of this given expression. Let's evaluate this limit and see what strategy can be useful to get this. Over here if I talk about x equals 1, at 1 you can very easily see you get 1 plus 1 2, 2 minus 2 0. Here also you get 1 plus 0 minus 1, that is again 0. So this is actually 0 by 0 form, indeterminate form. I am interested in applying the L'Hopital rule. What do I do is limit x tends to 1, differentiate the numerator, you get 1 by x minus 1 whole upon, again you get minus 2 plus 2x. Clear? This gives you what? Limit x approaches 1, 1 minus x whole upon 2 comes out common, x you already have, you get x minus 1. You can write this as what? Minus of x minus 1. Fine. and what are you left with is, as x, because this is defined at x equals 1 and it is continuous as well, I am just going to incorporate x equals 1 in the denominator and get minus 1 by 2 as my answer. Clear? So, minus 1 by 2 is the answer, which is not present in any of the options, so none of these is my correct option. Fine, that is how you evaluate this limit. Next we have, what as the question? Let's see. 1 plus x square minus e to the power x whole upon x square. Okay, so over here, as you can very easily see, it is this particular expression which is going to create a trouble if it creates. Everything else is algebraic, this is exponential. So what we do is, this is limit x approaches 0, 1 plus x square minus, now e to the power x, you know what is the expansion, it is 1 plus x square by 2 factorial plus x cube by 3 factorial and so on, whole upon x square. So now when you open up the bracket, you get 1 plus x square minus 1 minus x square by 2 factorial minus x cube by 3 factorial and so on, whole upon x square, and its limit I need to evaluate as x approaches 0. So 1 minus 1, x minus x gets cancelled out, x square upon x square gives you 1, this gives you 1 by 2 factorial, then onwards what you start getting is minus x by 3 factorial and so on. All the terms from here onwards have x in them, at least one x in them, and therefore when you substitute x equals 0, you are just left with 1 minus 1 by 2, which is 1 by 2, because everything else becomes 0 upon 3 factorial, 0 upon 4 factorial, 0 upon 5 factorial, which is all 0. When you add all the zeros, you get 0, and therefore you are just left with this particular positive expression, which is 1 minus 1 by 2, that is 1 by 2. So your answer is option number C. Next we have, if limit extends to 0 of this expression is e square, what is the value of a and b? Okay, let's see. Now over here again you can see there is this 1 by x in the power, right? Somehow again reminding me of the same result. Let me write it again. It was limit x tends to a, 1 plus fx whole to the power 1 by gx is equal to e to the power limit x tends to a fx by gx. Right. Now over here 1 by gx is fine, gx is x, that means. But what is fx? I need to write this as 1 plus something. So this will be written as limit x approaches 0, 1 plus cos x minus 1 plus a sine bx. So 1 plus fx to the power 1 by gx. X is what? Your gx. Now, if this limit is equal to e square, so this is already given to me that this limit is equal to e square. In that situation, what do we do is, if this is equal to e square, I am going to use this result. This is equal to e to the power limit x tends to 0 fx upon gx. So it is cos x minus 1 plus a sine bx whole upon x, and this complete expression is given to you as e square, right? So what we do is we basically segregate the terms and plug in x beneath each of these terms. What do we get is e to the power limit x approaches 0. I have cos x minus 1 whole upon x. Now see, I can write this as plus a sine bx whole upon x. But you have to understand that limit of the sum is basically sum of the individual limits. So what I can do over here is, this is a sine bx upon x. Clearly, because x is approaching to 0, one basic result comes to my mind, which is limit x tends to 0, sin x by x is 1. So what I do is I basically make the argument same as the denominator by multiplying and dividing by b. So over here now you can understand, I can just segregate the limit as well, because again as I said, limit of the sum is sum of the limits, and this is given to me as e square. Now see over here, if you plug in 0 in the numerator and denominator, you get 0 by 0 form. So what you do is individually, let's evaluate this, you apply the L'Hopital rule. What you get is minus sin x minus 0 whole upon 1, and in this when you apply limit x tends to 0, you basically get a 0. So this is e to the power 0 plus something. What is this something? I just told you limit x tends to 0, sin x by x is 1. So if x is tending to 0, bx is also tending to 0 obviously. So sin bx by bx is also 1, a into b is constant, so it is 1 into ab, that is ab. So what you are left with basically is this limit comes out to be ab. ab into 1, that is ab. So you have e to the power 0 plus ab, that is ab, equals e square, that means ab is 2, it is a 1 1 function, right? AB is 2. Now for what value of A and what value of B, A into B can come out to be 2. Let's see, obviously if A is 2 root 2 and B is 1 by root 2, you get A into B is 2, rest none of the options are going to suffice for this. So C is the correct answer. Clear? Next question says, this is pretty interesting. It says if the graph of the function fx has a unique tangent. So first of all, the graph of the function fx has a unique tangent at the point a comma 0. The fact that the function has a unique tangent means that the function is differentiable at this particular point. The moment I am saying function is differentiable means it's obviously continuous at the point, and the fact that it is continuous itself reminds me to use all the concepts which continuity brings with itself. So if the function has a unique tangent at the point a comma 0, this one thing that I said is clear to us, that okay, function is differentiable, function is continuous at this point, that's fine, cool. But also one more thing is here, that a comma 0 is obviously lying on the graph of the function. If a comma 0 is lying on the graph of the function, very clearly f of a is 0, then only it is lying on the graph of the function. That means f is basically sending a to 0, that means corresponding to a, the image that is coming out is 0, so f of a is 0. Or a comma 0 is lying on the graph of f. Then evaluate this limit. Now understand, it is log of 1 plus something upon something. Very clearly I can remind myself of this particular result, that limit x tends to 0, log of 1 plus x whole upon x is 1. Let's try to create that scene over here when we know this, and we also know that f is continuous at a. F is, why? Because it is differentiable, right? So it is continuous as well. So now I have limit x approaches 0, log of 1 plus 6fx whole upon 3fx. Now I don't want 3fx, it is 1 plus whatever, that same whatever is written in the denominator. So to get 6fx, I already have 3fx, I multiply and divide by 2, so I basically get a 2 outside. Now, can I directly write 1? I cannot do that, because this result is valid when whatever is here and it is tending to 0. So whatever is here is definitely here, but 6fx is tending to 0 or not? Over here, this is actually a, because this particular point is a, it is limit x tends to a, here also it is limit x tends to a. I want 6fx should tend to 0. In that situation, this entire thing is going to be equal to 1. Now see, if x is tending to a and f is continuous at a, this is very beautiful, x tends to a and f is continuous at a, this implies fx tends to f of a, but f of a is 0, so fx tends to 0, which obviously means 6fx also tends to 6 into 0, which is 0. So basically if x is tending to a, then 6fx is obviously tending to 0. So 6fx tending to 0, log of 1 plus 6fx upon 6fx is 1. So you get 2 into 1, that is 2 as your very answer. Very nice question, because over here the one line that there is a unique tangent itself made a lot of points clear to us. Continuity was brought into picture. The fact that continuity brings with itself that x tends to a and f is continuous at a means fx tends to f of a. All these were used and you got your very answer. Okay, so practice the questions very nicely. That's it from my side. Thank you.